applications are some of the more complicated ways that we look at the law of sines and the law of cosines. There's really nothing to say, but it involves taking your time and really being able to draw your visual. The biggest thing I can recommend to any and all students who are working math and are working with applications in a trig or pre-calculus class is that you need to draw the picture of what's going on, mostly because a lot of your problems are going to deal with rotating angles. You're going to have to figure out where the variable is that you're actually searching for and what information out of your problem really pertains to what you need and what is added extra. Okay. So I have roughly 4 very different examples, all of which are going to use either the law of sines or the law of cosines to be able to solve, and all of which apply using the different knowledge of angles and triangles in order to complete. Okay, so let's go ahead and jump right in. So here we've got that Sanchez Irrigation is installing a lawn irrigation system with 3 heads. They determined that the best location for heads A, B, and C are such that angle A or angle CAB is 40 degrees, angle ACB is 45, and the distance from A to B is 34. However, they need to calculate the distance from B to C. So we need to actually draw this picture to even get started. So first, we're working with a triangle. So let's go ahead and set up our triangle. So we have a triangle here, and we'll just go ahead and label it A, B, and C. And now we have to put in the information that we actually know. So we know that angle CAB is 40 degrees. So in order to do that properly, again, it says you start at C and we're going to go from C to A to B. So we're talking about this angle right here. And this is going to be 40 degrees. And we also know that ACB is 45. So we have A to C to B, so this angle here is 45 degrees. We know the distance from A to B is 34, so that's this distance here, and so we know this to be 34 and its feet. What we want is B to C. So the place that we are looking for is we are looking for this length here, which would be the same as saying length A. So if you notice, we have side angle side, which is a law of sines application. We have the missing side across from an angle. We have a known side across from an angle. That's the other way that you can determine if you're using law of sines or cosines. So here this is law of sines. Law of sines says A over the sine of A is equal to B over, say, the sine of B is equal to C over the sine of C. That's the law itself. So here we don't know A, so we have A over, but we do know angle A. So this is going to be the sine of 40. We don't know anything about angle B or side B, but we do know my pair of C's. So this is going to be 34 over the sine of 45. So we just simply need to solve for A. So here A is going to be 34 sine of 40 all over the sine of 45, which is going to give you 30.9 feet. All right, let's look at another one here. An airplane flies 730 miles from Charleston, South Carolina to Cleveland, Ohio, with a bearing of north 30 degrees west. The plane then flies from Cleveland to Dallas at south 42 degrees west bearing. How far is Dallas from Charleston? Assume Dallas and Charleston are at the same latitude. So this one's going to involve a little bit more thinking. First of all, the biggest thing that we have to remember is we are now dealing with bearings. Bearings deal with your compass. So if you remember our compasses, okay, where they point or start with north, and then we have south, we have west, and we have east. So when we're talking about a bearing of north 30 degrees west, we are talking about you go from the north and we're going to go 30 degrees to the west side. Okay? So north 30 degrees west would kind of put our angle, we'd be coming over this way. Now, if we're talking about south 42 degrees west, it's the same thing. You're going to go to your south, and we are talking about going 42 degrees west, so going that direction. Okay, so that's kind of how your bearings work. You go from your starting point, and then this tells you how many degrees towards the other direction. So let's actually start trying to put together our triangle here. So we've got northwest and southwest. Okay, so let's go ahead and we're going to drop in. Notice I'm going to make it fairly big so that we can really kind of see what's going on here. So the first thing we have is we are told, let me go ahead label, here's my north. So we are told that we are going from Charleston. So we are going to label this right down here at the origin as being my South Carolina, or my Charleston, South Carolina. And we are going to travel to Cleveland, Ohio, and we're going north 30 degrees west. Okay, so we are going roughly, and notice I'm not making it absolutely perfect, we just need to get a rough idea. So we are going roughly in this direction. Okay, now what do we know? We know that this distance here is going to be 30 degrees. We also know that where we stopped right here is going to be Ohio. Okay. And so at the moment, that's the information we have. Okay. Now, the other thing we know is that our little plane is going to turn around. So one of the things that I like to do is when we turn around, I like to go ahead and drop in, I need a new compass line, and it's going to sit right here at my point. Again, remember this is north, and I'm going to go south 42 degrees west. So from my south side, I'm going 42 degrees this way. So we're going to go ahead and spin our point down. And so now we're going to come down this direction. And we're supposed to assume that Dallas and Charleston are on the same latitude, so that right here is going to put my Texas point right there. Okay. So we actually have our triangle here. Now, the other piece that we know is we know that from this south line over to here, so this little piece right there, is going to be my 42 degrees. Okay. So that's the information that just this piece has given us at the moment. The only other thing that we have is that we know the plane is going to fly 730 miles from Charleston, South Carolina to Ohio. Okay, so we know that this distance, or this line right here, is going to be 730 miles. Okay, that's everything we know. We do not know what this distance is, but we want to know how far Dallas is from Charleston. So this distance right here, I'm going to go ahead and do it in red, but I'm going to offset it just a smidge here. Let's offset it down here. So this is the distance that we are looking for. This is the unknown piece, okay, between my Texas and my South Carolina. So this red line right here is what we're looking for. So we need to start trying to fill in some of the other information that we have, because at the moment we do not have enough to be able to do anything. First of all, the only distance I know is this side. So if I want to use law of sines, I have to be able to figure out this angle. The only way I can figure out this angle is by figuring out this missing angle and the other piece to this angle up here. Okay? So, the first thing I need to find is I need to find this angle. So this one right here, I need to find. Well, to do that says that I have to take my fact that this is a right angle. So in order to find, let's call this alpha. So in order to find angle alpha, I have to take my 90 degrees, subtract the 30 degrees that I know of, and that's going to leave me with 60 degrees for that angle alpha there. Okay. So how exactly does that help? Well, if you remember, in a geometry class, we have a rule that says if you have two parallel lines, so these two north lines, these would be two parallel lines here, you cut them by a transversal, then your opposite interior angles will be the same. In other words, this little small piece is 30, which means if I come up here, this little small piece from my south over here, okay, so let's call this beta. Well, your beta angle also has to equal 30 by using that rule. Okay, again, that rule says two parallel lines that are cut by a transversal means your opposite interior angles are the same. Okay, so now we know this little piece to be 30. So if we look at this large piece, so this piece right here, okay, let's call this one gamma. Well, gamma has to be the addition of these two little pieces. So gamma here has to be my 42 degrees plus the 30 degrees based on my geometry rule, which says that this rule has to be 72 degrees. Okay, so that's what's going on right here. This is 72 degrees. Knowing that, we can calculate the missing angle. So this angle here, which is one of the things that we definitely needed, was this angle here. Let's call this one theta. We can use our triangle rule for that. So to find your theta says all three triangle angles have to add to 180. So I'm going to take my 180. I have to subtract away my alpha angle, which was 60. I need to subtract away the gamma, the big angle of the triangle, which was 72. So when I do that, I find that my theta angle is going to be 48 degrees. So I have an angle with a side. I have an angle with a missing side. So this tells me that I can use my law of sines. So I am going to have my side, so 730 over the angle I just found, so sine of 48 is going to equal my missing side over my gamma angle. So this would be the sine of 72. Solve for x and we have our answer. So here we would have that x is equal to 730 sine of 72 over the sine of 48. So my angle x is going to be 934.2 miles. And when you're finding your final answers, always make sure that your rounding matches information you've been given in your problem. If none of your answers here are decimals, then usually 1 or 2 decimal places will suffice. The other place where you can always look up in your problem and see if it tells you how to round. Okay? But there you go. So here it would be 934 miles, 0.2 miles between Dallas, Texas and Charleston, South Carolina. All right, let's look at another one here. So we have a plane took off and ascended for 1,000 feet before leveling off. Once the plane flew for 500 feet, which put it 1,480 feet directly away from where it started. After leveling off, what is the angle between the plane's current horizontal flight path and its ascending flight path? So we need to, again, kind of draw ourselves a picture here. So the first thing that I'm going to do is I'm going to input my ground space. And now we have to look at what are we saying. And it's saying that the first thing we're going to do is we're going to take off and we're going to ascend. So we're going to go ahead and take off here. And we're going to travel up to a spot. And it says that we took off for 1,000 feet. So this is 1,000 feet before leveling off. So leveling off essentially says we're now parallel to the ground. So we're going to go ahead and draw myself the parallel. And it says flying for 500 feet. So we are flying in this direction and we've now gone an additional 500 feet. So the question wants to know the angle that we have. So if we look, we actually have a triangle here. And one of the things that we were told is we were told that after flying 500 feet, we are 1,480 feet away from the starting point. So that makes this 1,480 feet. And we want to know the angle between the plane's current horizontal path, so this path here, and the ascending flight. So we are looking for this angle right here. Okay? We can go ahead and call that angle theta. So that is the missing angle. So if we look closely at what we've got, we have 3 sides and a missing angle. So here we are going to use the law of cosines this time in order to find our information. So the law of cosines essentially says that we have to take a squared equals b squared plus c squared minus 2bc cosine of a. So here the angle A would be my missing angle, so across from it is going to be a squared. So this is going to be 1480 squared is equal to 1,000 squared plus 500 squared minus 2 times 1,000 times 500 cosine of theta. So the first thing that I would do is I would square all of these into my calculator. you're then going to solve for your theta angle. So here we're going to end up getting 0.9404 is equal to the cosine of my theta. To solve this, we would say my angle is equal to the inverse cosine of my decimal. So my angle is equal to 160.1188 degrees. Alright, here we have that a ranger in a fire tower, in fire tower A, spots a fire at a direction of 295 degrees. A ranger in fire tower B, located 45 miles at a direction of 45 degrees from tower A, spots the same fire in a direction of 255 degrees. How far from tower A is the fire? So we've kind of drawn part of a triangle here for you to see, but we need to kind of figure out what's going on. So first and foremost, this dotted line here represents your compass, north. Same with this dotted line here. This represents your compass. So the first one says that the ranger here at A is going to spot the fire in the direction of 295 degrees. So if you start here at north and you spin around like this, this solid line here is actually going to be 295 degrees from what we're seeing. Okay, that's how we got this solid line here from A to C. We need to do the same thing with Ranger B. They're located and it spots the fire at 255 degrees. So again, we would spin from north and we would spin around 255 degrees, which is how we found the line from B to C. Now the other thing that we know is we know that Ranger B is located 45 miles at a direction of 45 degrees from Tower A. So that means if we start at Tower A, the distance from north to this first line, my line AB, has to be the 45 degrees. And that also means this distance AB here has to be 45 miles. Now, from there, there's a lot of things that we don't know. So we need to kind of label in what it is we don't know so we know what it is we have to find. So, first and foremost, we do not know this little distance. Well, we don't know this distance here. So this distance from north down to my line here is an unknown distance. So let's go ahead and call that little a. I then, if we increase this piece out on our compass a little bit, the distance from our compass down to here, okay, so this distance here is unknown, we can call that b. The other thing that we don't know is we do not know the distance of this opening here, so this distance here, we can call this little c. I do not know my distance down here, so let's call this D. Furthermore, AC I don't know, so we can call that Y, and BC I don't know, which we can call X. So that is a lot of unknowns in our problem. So the first thing that we need to do is we need to find the missing parts inside and dealing with our angles to our triangle. Okay, so let's go ahead and start with finding little a. To find little a, so remember that's this piece right here, we have to remember that to go a full circle is to go 365 or 360 degrees. We've only gone 295 if we look at it. So to find little a says I need to take my full revolution, 360, and subtract what we've done, 295. This is going to make little a equal to 65 degrees. Okay, so we know little a here is going to be 65 degrees. Now let's go ahead and take a look at b. So let's find little b here. So here's little b. And there's a few things that we know. First of all, if I want to go 3/4 of a revolution, that's the same as going 270 degrees. However, I only went 255 degrees. So that means my little b, this distance right in here, has to be 15 degrees. So my little b here is 15 degrees. Now, if we were to extend that down so we can see it, we have to be able to find c here. In order to find c, we have to recognize that, first of all, this whole piece right here is going to be 90 degrees. Second, we can use the idea of alternate angles. So to find this piece here says that we have to use that idea of alternate angles. Okay? Alternate angles again says that if I take two parallel lines, so look at that's your north, okay, these two lines here, you cut again by the transversal, so that's AB is your transversal, alternate interior angles are the same. So this little angle is 45, that makes this little angle here 45. So in order to find C, C uses the idea that this quarter is totaled to 90 degrees, but we have 15 of it that we calculated, and we have the 45 that we calculated. So when we do all of that, we have to look at what's left, and what's left is 30 degrees. So that makes this angle C here 30 degrees. Now to find D, D is going to use the sum of the angles of a triangle. Okay, so to find D says that I have to take my 180. I know this piece of my triangle is angle C, so I subtract out my 30 degrees. But then I have to subtract out my angle A. And I know my angle A is made up of 65 plus 45. So I have to subtract out that 65, and I need to subtract out that 45. So that is going to make it so that my angle D is 40 degrees. So this is 40. Now furthermore, in order to actually use this information, I have to look at the missing pieces I have. I'm trying to find X and I'm trying to find Y. So I need to know the full angle A here. So I need to make myself a little note so that I know exactly what's going on. So here's my little note to myself, which is going to help. I know that angle B is going to be my 30 degrees. I also know that angle C is going to be the 40 degrees. And I know my angle A is going to be the 65 plus 45, which is going to be 110 degrees. So I've got my three angles. Now, to go with them, angle B's opposite says that side B is equal to y. I don't know it. Opposite of angle A says that my side A is unknown. And the opposite of angle C says that side C is equal to 45 miles. So I have everything that I need to get started. Okay, and here I can go ahead and use my law of sines. So the first thing I have is I have my x over the sine of 110 is going to equal 45 over the sine of 40. So to solve for x simply says I have to rearrange. So I get 45 sine of 110 over the sine of 40, which in the end is going to equal 66 miles. I need to do the same thing for my y. So here I'm going to have y over the sine of 30 is equal to 45 over the sine of 40. So to find y, says I do 45 sine of 30 over the sine of 40, and this is going to end up being 35 miles. So to answer our question, the first question said, how far from Tower A is the fire? So from Tower A to the fire, because remember, angle C right here was your fire. So this was to find the length of y, which we found to be 35 miles. The second part says from Tower B. So from B to the fire is x, which we found to be 66. And notice in this problem it said round to the nearest whole mile, which is why we rounded these two answers. Whew, that took a lot of rotation. Alright, let's look at one more here. So I have two airplanes leave an airport at the same time. The first flies 150 kilometers per hour in a direction of 320 degrees. The second flies 200 kilometers per hour in a direction of 200 degrees. After 3 hours, how far apart are the planes? So let's go ahead and set up this picture here. So we have our little compass. Okay. So first and foremost, we know that this spot right here is going to be the airport. Okay, so let's go ahead and label that. Alright, so the first thing that we know is we have that the first plane 50 kilometers per hour in a direction of 320 degrees. So what we actually want to do is we want to go from north. So remember, this is going to be north. And we are going to start from north and we are going to spin 320 degrees. So again, this is 90, 180, 270, 320 is going to be up here. So I'm going to go ahead to make things easy. I'm going to use my straight edge here. And so 320 is probably going to be somewhat close to that. So let's go ahead and do this. And we'll go here. Okay, so it goes in this direction. And what we did was we started at north and we spun around like this, and we went in a direction of 320 degrees. Now there's a few other things that we know about this. We know that this is going to travel 150 kilometers per hour, and we know that it's going to go in that direction for 3 hours. All right, let's look at the second plane. The second plane says that we are going to go 200 kilometers per hour in a direction of 200 degrees. So again, we start at north, and we go 90, 180, 200. 200 is going to be down somewhere around here. So we're going to go this way. And we are going to travel in this direction. So again, we went starting out here. We went down around for 200 degrees. We also know that this plane here is going to be going 200 kilometers per hour for the same 3 hours. So here, this would be my plane 2. This up here would be my plane 1. So we've kind of got this where we can connect it. So we've got this, so I'm going to draw my little dotted line because we need to know how far apart they are. So when we're looking at that, we're actually looking at the distance between P1 and P2. We need to know how far apart this distance is actually going to be. So we would kind of label this with X because we don't know what that distance is. Okay? So we need to do a little bit of work to see what we're actually doing. So the first thing we need to do is we need to actually calculate the kilometers here. So in order to do that, you would take this 150 times 3 hours, and this here is going to give us 450 kilometers. Okay, so this distance for P1 is 450 kilometers. We need to do the same thing for P2. So 200 times my 3 hours is going to give us a total of 600 kilometers. Now for the fun stuff. We need to figure out some areas here, or some angles. So the first thing that we don't know is we do not know my angle here that goes from my first plane kind of down to my axis line. So we don't know that. But what we do know is we do know that to go from the start all the way over was 320 degrees, and we do know that if we had only gone 3 sections, it would be 270. So to find this missing piece, let's go ahead and call this alpha. We would say that my angle alpha is equal to what I went, which was 320, minus 270. And that is going to give me this missing distance right here, which is 50 degrees. Now the other piece that I need is I need this distance. So again, I'm looking at this big distance here because I'm trying to find these angles. This is what I'm looking at. Let's go ahead and call this one beta. So again, if we take a look at it, if I had gone all the way around to my third, this would be 270, because if you start at north, we go 90, 180, 270. But I didn't go 270, I only made it to 200. So to find beta, would say I'd take the 270 that's known. I only went a 200 degrees. And so here this would leave me with 70 degrees. So what I have is I have 2 sides that are known, a missing side, but I know the known angle. Okay? So if we look at the angle at the airport, that is going to be my alpha plus beta. So in this case, it's going to be 50 plus my 70, which equals 120 degrees. So this whole angle right here that's missing, okay, is 120 degrees. So I can use my law of sines. So here what this would say is that my missing side, so my x squared, is equal to my known side, 450 squared plus 600 squared minus 2 times 450 times 600 cosine of 120 degrees. So you would go ahead and use your graphing calculator, and you should come up with your distance being 912 kilometers. Do make sure at the end you remember you got to take the square root of all of that stuff in order to find your actual distance. So do take a minute and make sure that you plug this into your calculator on your own and double check that you came out with the exact same quantity. So there you have it. Okay, again, what all 5 of these problems have come down to is recognizing the way you're spinning on your compass, the way you're calculating your angles, and then being able to decipher which law you're going to apply, whether it's the law of sines or the law of cosines. So if you have any questions on these examples, please let me know. If you have any other examples that you are totally stumped on and you would like me to take a look at and solve, let me know that too. I would be more than happy to go ahead and do that for you. Otherwise, do be creative. I hope you enjoyed this lesson. I hope you enjoy working these problems out for yourself, and I'll see you next time.